Hello everyone, thanks. This is part of the Kubeflow dojo, which we are running in terms of ensuring that we can have both users and contributors who are excited or who want to understand the value proposition of Kubeflow overall. Can get some knowledge and get started on individual components. And one of the components today, which we are going to discuss as part of this uh, section of the dojo, is Kubeflow pipelines. And more so specifically Kubeflow pipelines in the context of with Techtron as a backend. Before I go into more details, right, let me introduce myself. My name is Animesh Singh. I'm the Chief Architect for Data and AI Open Source Platform strategy. I am also the lead for IBM's Kubeflow engagement. With that, I'll pass on to Christian. Christian, do you want to go next?
Hello, everybody. My name is Christian. I've been working with Animesh and Tommy for quite a while on Kubeflow, and especially Kubeflow with Techtron. And I will explain more about the specific work we had to do to integrate a Techtron backend with Kubeflow pipelines.
Thanks a lot, Christian. Tommy?
Hi, my name is Tommy. I'm a software developer under the IBM open source team. And I also contribute with Kubeflow and work with Animesh and Christian under this project.
Thanks, Tommy. So I think one thing which I do want to cover is, overall the breadth of the Kubeflow portfolio, right? This is a slide we will use to introduce a lot of our dojos. So Kubeflow is, an end-to-end machine learning platform built on top of Kubernetes with focus on build, train, deploy, and manage. For build, there is Kubeflow Notebooks, which is your entry into using Jupyter Notebooks on Kubernetes in a scalable fashion. For training, there is distributed training operators around TensorFlow, PyTorch, MXNet, MPI, etc. There is hyperparameter optimization piece called KATIB. There is a serving project called Kubeflow Serving or KF Serving, which brings TensorFlow Serving, Selden Core, and other technologies also together. And finally, we have Kubeflow Pipelines, which essentially ties this whole end-to-end machine learning lifecycle together. And today's section is going to go deeper into the Kubeflow Pipelines. So essentially, the core idea behind Kubeflow Pipeline, the primary origination point was end-to-end ML pipelines on Kubernetes, right? So Kubernetes or cloud native is the main core construct. So that lends itself to containers, right? So the different steps or tasks in the pipelines are essentially containers running on Kubernetes, right? So that reflects back, as you start looking at a pipeline from a top-down perspective, and the adaptation of to ensure that it reaches out to data scientists in a very friendly manner is by creating a Python DSL. Now that DSL not only makes it possible for regular Python to actually craft these end-to-end pipelines so that, previously if they were just, creating an initial model or training an initial model, now they're empowered. They have a toolkit at their disposal to actually go further steps, right? So they can not only train, they can validate, they can deploy, at least in a staging environment, right, before they hand off to the prod. They can enable monitoring, they can enable drift detection, anomaly detection, all through, a single Python DSL, which they can use to craft these pipelines. And then, you get more Kubernetes native capabilities exposed through this DSL as well. Things like secrets, config maps, volumes, volume snapshots. So, I mean, most of the data scientists, when they're working in enterprises, they're probably working on a platform which is running on top of Kubernetes, and most of your data which you are interacting with is probably backed by storage, which is abstracted through Kubernetes mechanisms, plus the authentication, authorization, secrets, etc. You're using a lot of the Kubernetes paradigm. So the DSL makes and does a great job of abstracting a lot of these, through the Python interface. And then you get additional scheduling a cron job, or having triggers, external triggers to be tied in to execute these pipelines. This is how the DSL looks like. Now, if you look at this DSL, it's probably 14 to 15 lines of Python code. But what it is actually doing is, right, in this case, you have a pipeline which is essentially, using TensorFlow's data validation component to do data validation. Then it's using the pre-processing component, which is part of the TFX umbrella, to pre-process that particular data, do schema generation, etc. Then there is training, right, which is essentially running distributed training using TensorFlow under the covers. And once your training model, you have TensorFlow model analysis, which runs analysis on top of that model and decides, right, whether it is fit to move to deployment, right, which is your production deployment on top of TF server. So just by using, 14 to 15 lines of code, a data scientist can go all the way end to end, starting from initial data to pre-processing data to training a model to validating a model to deploy a model. Now, a lot more capabilities got added in Kubeflow pipelines, right, to make it more useful and provide more capabilities for data scientists in general. I mean, for a lot of us, right, who are actually doing a lot of data science, we typically tend to understand the world in terms of graphs and statistics, right? So Kubeflow pipeline gives you a plugin mechanism to inject your own graphs, ROC curves and other things as a plugin, so that, as you are running your pipelines, you should be able to visualize the different results as they are, being calculated as your calculations are going on. Some of the capabilities where essentially machine learning world is very, very experimental. You are probably, doing multiple experiments, producing multiple versions of these pipelines, right? So having a robust versioning capability is a must. And artifact tracking, right? So this is another thing, right, which becomes very, very important in the machine learning world. Given the fact that you probably start from a data set, and as you move towards a production ready model, you are producing a lot of artifacts, right? Whether it's a modified data set where you have, done some schema manipulation, or, you have modified, some of the features and the samples in the data set, or, when you have your initial model, which is untrained. Next, you have a trained model, and you probably are further training it. Then you validate that model, so you have a validated model. So over the course of this life cycle, you produce many artifacts, and you want to be able to make sure that, once your pipeline has completed, you have a view into what artifacts have been produced and go and look at the details of those artifacts. Another important capability, right, which Kubeflow pipeline has introduced is lineage tracking. Now, this becomes, again, all the more important when you are looking at the current world where models are making very, very important decisions, right? So in a lot of cases, a model is deciding whether you get admitted to a university or not. It's deciding whether you get a loan or not. You are putting your resume on a company website, and the model is essentially, discarding or enabling it. So the models are making, real life-changing decisions at this particular point in time. And in a lot of cases, right, those decisions can be wrong or can be debated, right? And when they're debated, right, this gives an ability to auditors or folks, right, who actually want to go back and trace, okay, this model is giving predictions, good or bad. Now it's a prediction which is debated for some reason. We can go back and trace back the lineage of that whole model down to the point, okay, this model was trained on this data set with this version of PyTorch, with these hyperparameters. These were the validation characteristics, and finally deployed and tested with this particular input test data set for scoring, right? So you have the whole lineage in your hands in case, you need to reproduce why the model did what it did and what were the ingredients which were used to make that particular version of the model. So I think by now, we have established that, the Kubeflow pipeline team has done a great job in terms of, creating a end-to-end MLOps solution, which can, enable both the data scientists to get much further in their journey. So not just in the model and hand over your Python code, you are able to go further, you're able to validate, deploy your model, test them, but also, ML engineers and DevOps folks, single consistent platform to go and look back at the logs, enable recurring runs, creates cron jobs, create, more triggers, etc. So suited for both of them. Now, when you look at the architecture here, right, how is it enabled? So there are different points. For example, there is an SDK for Kubeflow pipeline. And there is also an entry point is called the TFX, or the TensorFlow Extended Umbrella. Now, over a period of time, both these SDKs, they will be merged. So you will have one single SDK to orchestrate both the Kubeflow pipelines as well as the TensorFlow Extended pipelines, right? So SDK is very, very important for data scientists. The Python piece of it, which allows you to, take your DSL, compile it, launch it, run it. You can use it in Jupyter notebooks, embed it and use it. Then there is the lineage and pipelines UI, right, which essentially is your view into the world once you have launched your pipelines, right, and you want to get more details around the logs, the inputs, outputs, the lineage tracking aspects of it. Now, under the covers, this is backed by default through a CI/CD engine called Argo. Argo is a project which started out of Intuit. Now it has become very popular. It's part of CNCF. And the initial version of Kubeflow pipeline, which rolled out, right, it's built on top of Argo, and it handles a lot of the underlying CI/CD aspects which Kubeflow pipeline needs, right? Now, in addition, you can, there are specs how to build your custom components, which you can plug in, and you can define, specs around the inputs, outputs, and what the component does. And we can cover, some of those details as a follow-on as well. Now, this one goes into much more detail, so I will probably not spend too much time on it, right? But the idea that, behind the scenes, when you actually upload the pipeline, right, and you're running the pipeline, there is a lot which needs to happen, right? I mean, you need to have, for example, persistent agents, right? So your pipelines need to be stored in object storage, which is S3 compatible object storage in this case. And there is the metadata on those pipelines stored in a relational, which is MySQL database in this particular case. And then, you need to have more mechanisms around log archival. So, you are archiving the logs and putting it to a persistent storage. So a lot of those capabilities are built in. You saw the lineage tracking UI, which is built on top of a backing technology called MLMD, Model Management Database, which came out of the TensorFlow portfolio, but is also, the backing database behind the TFX pipelines, right? So that's the one which defines the schemas and is responsible for storing, information related to, the artifact tracking or the lineage tracking related use cases. Okay, so this is, we talked about, why Kubeflow pipeline is so useful for machine learning and AI world and the capabilities it brings to both AI developers and data scientists, as well as, MLOps engineers or DevOps folks who want to ensure that it is running in production in a consistent manner. And we also talked about, the underlying architecture. So what are we doing in the context of IBM and Watson precisely? So earlier on in the year, Watson made a decision to actually productize Kubeflow pipelines and use it as part of the Watson portfolio for end-to-end AI orchestration. And as part of doing that, right, one of the preconditions and one of the architectural changes which we are doing to enable that is that instead of using Argo, using Techtron as the underlying engine. Now, a couple of primary reasons for it. IBM Cloud has standardized on Techtron as the underlying CI/CD pipeline. In addition, OpenShift Pipelines, which is our on-prem portfolio and very popular Kubernetes distribution, that also uses Techtron as the underlying pipeline technology, right? So it made sense from a strategy perspective, as well as, ensuring that we have one support cost development infrastructure that we base it on Techtron, and that was the goal given to us by Watson. And additionally, the way Watson is looking at it is creating definitely, different entry points. How do you actually not only craft these pipelines using a Python DSL, but also using a drag and drop mechanism, and then, integrating it with the rest of the portfolio into the cloud pack for data, like auto AI. So, essentially, if models are being trained using auto AI, how do you actually use Kubeflow pipelines to take them, into the next steps of the pipe life cycle using data refinery flows, right, which are manipulating a lot of the data-oriented tasks within the Cloud Pak for Data portfolio. So it's being integrated with a large part of the Cloud Pak for Data portfolio. Okay, so what is Techtron? Right, so I mentioned, Watson gave us a goal that thou shall run the of Techtron. Now, Techtron, like Argo, cloud native and more Kube native, I would project which originated initially under the Knative umbrella, but branched out on its own and moved to CD Foundation. So it's part of the Linux Foundation now and being used heavily by a lot of vendors. And there are a lot of major contributors: Google, Red Hat, IBM, contributing heavily to it. And at an architectural level, everything is architected as a Kubernetes custom resource definition. So that means there is a concept of pipelines, definitely, right? But backing those pipelines are tasks, which are then made up of steps. And typically, you have steps and tasks, right? Essentially, which are then mapped to pods. So essentially, all the steps within a particular pod are container. And essentially, this logical grouping allows us to handle one thing, right? In this case, the tasks become independent of the pipeline, so they have their own life cycle, in the sense that you can upload a task, you can launch a task, you have a task run. So totally independent of the pipeline, you can have the whole life cycle around a particular task, but then you can plug the larger task inside different pipeline components, right? So things to remember is steps, which are part of a task, right? And steps essentially run within the same pod. Tasks can essentially span certain pods, and then multiple tasks together make up a pipeline. So we divided the project, right? As we started looking at integrating Techtron as a backend within Kubeflow Pipelines, we divided the project into multiple phases. Started with 2 phases which were important to us, and then end the presentation with phase 3, which is where we are looking at it from a future perspective. Phase 1, essentially the idea that we want to create a Python SDK and compiler for Techtron, right? Now the only fact is that SDK and compiler, we want to base it on Kubeflow Pipeline DSL. So in this case, right, it has its own independent existence. Somebody was running Techtron and they want a Python DSL and a interface on top of it, they can use the SDK independently. But more importantly, from our goal, right, was phase 2 as well, where essentially instead of taking the compiled output, so you start from a Python DSL, compile it to a Techtron YAML, but now instead of going to Techtron directly, we want to submit that output to the Kubeflow pipeline engine, right? And part of that essentially is to ensure that we are leveraging the Kubeflow pipeline APIs, the next set of capabilities in the SDK, as well as the UI fidelity, right, which brings a lot more features and functions on top of this. So with that, I'll pass on to Tommy, who is going to talk a bit about what it entailed when we started looking at this integration from a features and functions perspective. Both Tommy and Christian have been heavily leading multiple aspects of this when looking at and mapping out the DSL features which are there on Kubeflow pipeline, and then what are the corresponding capabilities in Techtron, and how do we map them? Where do we find gaps, so that we need to work with the Techtron community and make sure those gaps are covered. So Tommy, do you want to go briefly through this?
Sure, no problem. So here you can see the list of features we currently support on our compiler to produce the equivalent Techtron pipelines. And on the top, you can see like things such as retry, volume, timeout, run after. Those are native Techtron features that we leverage to produce a Kubeflow pipelines. And for features that are not quite mature, such as artifacts, resource ops, output parameters, we actually take the approach in our compiler and make it more aligned with how Kubeflow pipeline represent the artifacts and parameters. And for more details on each of these features, you could also go on our GitHub repository and check out how we actually go around with our compiler implementations. Next slide. And here is the list of pipeline sample we are currently running with the Techtron backend. The first one is a MNIST end-to-end examples that use multiple Kubeflow components such as Knative and KF Survey, and we'll be showing this in our demo today as well. And then we also have pipelines that just test individually on Knative, on Trusted AI, just training and serving. And this also few more pipeline to demonstrate how you could just run Python code directly and conditions within Techtron using Kubeflow pipelines. Next slide. And here is our implementation for migrating the Techtron backend to Kubeflow pipelines. So in the left side, you can see on your local machine, first you have a SDK or compiler to just write a Python code in the DSL format and compile into a YAML or DGZ binary. And then you take that binary and then go to a Kubeflow pipeline UI and open it in the browser. And inside the browser, you could upload that binary, and the binary technically will take it to the backend, extract it, and put it into a minimal storage and record the pipeline metadata inside MySQL database. And once you have those uploaded, you could create a run that actually execute a pipeline run in the background with Techtron. And the backend will retrieve the status of the pipeline run and give you back the real-time status of the Techtron pipeline that is running inside the cluster. Next slide. And here, Animesh will talk about how you could use the SDK to actually run a pipeline on the Kubeflow pipeline UI.
I think we have probably talked a lot, and it's now time to show, but I will very quickly and briefly go through what you are going to see, right? So I think after this, Christian is going to give a brief walkthrough through the repository, and Tommy is going to show you this working end-to-end, right? But the idea which we mentioned, right, that you have the DSL which you can compile using the SDK, right? And then, this is essentially a snapshot from a Jupyter notebook where you can then launch it using the same SDK, the pipeline, and once you launch it, right, you can go and have the same experience which you have it onto the Kubeflow pipeline dashboard, which is essentially, you have the pipeline uploaded, you can get, the details about what are the input parameters, output parameters, etc. You can look at the corresponding backing YAML. Now, if you are using Kubeflow pipeline and you're familiar with it, one of the changes which you notice here is that instead of the familiar Argo YAML, what you see here is Techtron YAML, right? So same experience, same capabilities, but now in this case, right, the backend engine which is powering them is Techtron. You can launch the pipeline and look at the logs streamed in real time, step by step, how things are progressing, and if they're going in the right direction or not. And then once you have run the pipeline, you can actually go back and leverage the same capabilities around lineage tracking, right, which I talked about in the beginning. In this case, right, the previous pipeline, for example, which you saw is essentially, training a model using Watson Studio, DLAS, deep learning as a service, then storing the model into WML, and finally deploying that model using Watson machine learning. Now you can actually, trace back the whole lineage for that model once it has completed, right down to the point that, what was the final UID of the deployed model, right? What is the scoring endpoint for that deployed model? What is the UID of the trained model, right? And these enable you to then trace the artifacts, corresponding artifacts. You know the UID, the to the artifact, and you can drive into more details around that artifact, going back all the way, right, from where you started the pipeline in this particular context. One thing to highlight is that, even though you launch it through the Kubeflow pipeline engine, behind the scenes, the backing engine is then, when it goes to the lower levels, it gets executed in Techtron. So you can actually also, look at these pipelines into the Techtron UI running in a similar fashion, right? When you launch it from the Kubeflow pipeline dashboard, and you can, see the logs, etc. if you're used to that particular experience and are leveraging it. And last but not the least, right, before we dive into a bit more details around the GitHub repo and the demo, is essentially our phase 3, which is, in phase 1 and phase 2, we talked about, compiling the Kubeflow pipeline DSL to Argo or Techtron YAML, and then taking it to the Kubeflow pipeline engine or Techtron directly. But phase 3 of efforts will be focused around compiling it to what we call an intermediate representation. Now, that intermediate representation is, something which we are working together and aligning our efforts with what Google is doing with Kubeflow pipeline and TFX. And then we have a lot of requests in the community from Zillow, Lyft, etc. also for that, what we think will become, an industry standard representation for representing machine learning pipelines end to end, right? So stay tuned, a lot of more exciting things to come. And share our, some of the resources. And the first resource is obviously the GitHub repository here. So at this point, I will have Christian, walk you through the GitHub repository a bit before we pass on to Tommy to do some demos. Christian? Thanks. You want to stop sharing, and if you want to share your screen, Christian.
Christian, I think you're on mute.
You're on mute, Christian, still.
Okay, got it. They were hiding the button. I'm so sorry.
That's fine.
Can you see my screen?
Yes.
Okay, so if you go to Google and look for Kubeflow and Techtron, first result you should see is our KFP Techtron repository on GitHub. And when you land on the main page, you see all of our folders and files that we have there, and our main README, which gives you a good overview of what we've done in this repository and what we aim to do. And much of this Animesh has already covered in the slides you just saw. One of the points of interest here is, if you come in as a user and you want to try out our SDK, our compiler, and soon to be the API in the backend, which we're working. You do want to set up your KFP Techtron environment. You need a Kubernetes cluster. You can, follow the link for the getting started. So on this development guide, you have instructions how to install Techtron, how to install Kubeflow. Those are details that we go in a follow-up session. You will find how to get started with the Python SDK, how to install it, how to run it, what you need as prerequisites. We have a package on PyPy that you can install with pip install. There's a few first steps that you can go through to set it up, to make sure it runs. You can run the tests. You can compile one of your Kubeflow Pipelines DSL scripts, and you would see the output gets generated into a Techtron pipeline YAML file. And if your setup works properly, you can take that pipeline and run it on a Techtron cluster. And all of this is laid out here. And there should be enough detail to at least get started with a basic example. Furthermore, on the main README, you have links to the developer guide. If you're keen enough to actually contribute to our project, there should be steps here that explain what our code does, where to find things, how the code was written and why. There's a very good explanation to all the features that we have implemented, where the status is. Some of them are dependent on other repositories like Techtron pipeline features that we're waiting on. You can see our compilation status report. This report we generate in order to make sure that whatever we do on our compiler, we can take the original Kubeflow pipeline samples and the test data and compile those. And we'll see we have feature gaps. Some of those will fail, and we keep track of our progress. So currently we're at about 80%. Very interesting also is if you are already familiar with Kubeflow and Argo possibly, and you want to see what is supported with Techtron, there's a very detailed spreadsheet that shows you a detailed listing of features that are supported by Kubeflow pipelines, how they were implemented with Argo, how they are implemented with Techtron, and again, where the development state is. Some of those features have to still be implemented, some of them need workaround, and this spreadsheet has a very detailed list of those. It might not be up to date, but it gives you a good overview of what we're working on. Design doc is pretty much equivalent to what Animesh laid out. This is an official document that we share with the Kubeflow community that shows the 3 phases of our project and how we approached it. And last but not least, There's a link to the CD Foundation, the MLOps SIG group, along with details to the call that we have on a biweekly basis and additional reference material. With that, I'll give back to Animesh.
Thanks a lot, Christian. That was great. And one of the pages, which was also, the features comparison, which Tommy talked about, right? That's also listed in details there, right? So if somebody wants to access those, look at the chase, the details of corresponding issues or PR linkage to the Techtron report, that can be a good resource as well. Thanks, that's great. And with that, I think, Tommy, it's show time. So please go ahead and show a couple of demos.
Sure, no problem. So let me share my screen. So once you have Kubeflow deployed with the Techtron backend, you could go ahead and access the Kubeflow main dashboard. On your left-hand panel, you could click on the pipeline tab, and it will redirect you to the pipeline UI. And in the pipeline UI, you have 4 sections. One is the pipeline, show you what are the pipeline you have uploaded. And then this experiment where like the list of experiment to group a list of pipeline runs you have execute. And then artifact is the artifact that you have executed inside the pipeline, and they are also grouped with each pipeline execution as well. And then the execution is actually how those artifacts are traced. So you could see this component have executed this particular artifacts. And with this, I will go ahead and demonstrate a usual pipeline development flow. So first, you will need a Python DSL. In this case, we will code it in Python. So for this example, I will go over a pipeline that have 2 steps. One is to download a text file using the Google Cloud, and then the GCS command line. And then the second container, I will take that output and then actually echo it on the container. So here you could see the first component is using a GSUtil to actually download the text file. And then the second component is taking the text input and then echo it on the container. And at the end, we will construct the pipeline flow. So we will have 2 tasks that actually download files, and then put each of those files outputs into this echo task. And then we will compile this at the end. So in a typical flow, you will have these Python files. And since it in this Python, you could have a main sections where you could execute it using the compile functions. So you could just run Python and then the Python files, and this will create a YAML after the execution is finished. And this YAML is the valid Techtron pipeline runs that you could also upload on Kubeflow Pipelines. So with this, we'll go ahead on the Kubeflow UI and click on Upload Pipelines. And then do like upload a file. And then this is the YAML I just generated. And we could just drag over here and click Create. And this will give you like a flow view of how these components are connected together. So you have like 2 components that just download file and one to echo those output of the files. And then you can also see the YAML you just uploaded over here. And once you have it uploaded, you should be able to see it. This also lists on your pipeline view. And you could create a runs using this create run buttons. And in this section, you could rename your pipelines, add any description you want, and pick an experiment you want to group this run. So in this case, we'll just use the demo experiment. And then optionally, you can also pick a different service account, but in this case, we just use the default ones. And we will just run this pipeline once, and these are the 2 text files we'll be pulling down. And click Start to execute the pipelines. And as you can see, like this pipeline is the one we just created, so we click inside the pipelines. Since the pipeline will need to initiate the container, so it would take 5 to 10 seconds for the container to load. And once the container is finished loading, then you should be able to see the logs are showing up and how these are connected together. And in this case, since it produces an output and the echo takes an input, you can also see how the metadata is tracking them together over here. And inside the metadata, you could see there's a hyperlink. You could click onto the artifacts page. And this artifacts page would tell you how where the artifact is stored. You can also see what are the artifacts inside the S3 storage. So this actually pinging to an S3 storage to give you back the text file. And then you can also click on the Lineage Explorer and see how the flow is. So this case, we just have a GCS download 2 components to produce the data outputs. And the echo will take this data output and print out inside the echo container. And this is a very simple example flow. So I will going to show you a more complex flow with the Watson machine learning pipeline examples. So in these examples, we will have 4 steps. One is to create a secret for the Watson ML pipelines. And then once we have the secret, we'll use that secret to train the models. And you can see the secret is mounted to a volume. And once the model is finished training, it will pass down to a container to store the models. And once the model is stored, then it will deploy on the Watson ML deployment platforms. And you could also see like what are the input-output arguments from here. And for the argument that's produced from the previous task, you could always see it from ML metadata and track them using the Lineage Explorer. So in this case, you could see there's like 2 different output artifacts for the training. And when you click on one of them, it will show you how this artifact is used and who produces this artifact. And in the artifacts page, you can always go back to the particular components you want to visualize some of the metadata details. And now I'm going to show you one of the more complex pipeline with the MNext models. So for this pipeline, we're going to show you how to launch experiment using KATIP, a hyperparameter optimization platforms to train a MNext handwritten digit models. And then once that model is trained with optimized parameters, then it will create a persistent volume and actually converted the outputs and train it on these persistent volumes using more iterations to enhance the models. And once the enhanced model is finished, then it will serve using the KF serving platform, which is utilizing Istio and Knative. And in this case, we will serve with a canary deployments, which you could split the traffic between 2 versions of the models. And before we jump into this, we will show you like over higher view of the diagrams. So as you can see, the main pipeline is breaking it down to like 4 different fields. The first one is just processing the data in the first container. Second is actually do the HPO in KATIP, and behind KATIP, we're actually using the TF job to distributely train the MNext models. And once the model is finished, we actually train it with more iterations using the optimized parameters. And then at the end, we will inference the models by serving the model using KF serving. With this, I will show you like a quick demo videos because this pipeline we're going to run for a while. So once you have the pipeline ready, we will create a pipeline runs. is the flow will be very similar, where we just pick an experiment and make sure the parameter is correct. Then we click on start. And once the pipeline is start running, you could see the pipeline finish have a green check sign, and the pipeline that's still executing have a blue refresh sign. And you could see like how the metadata are tracked, and also the pod and events during the pipeline run. And then once you are like having, because this pipeline is using kdif, so behind the scene we actually have kdif to find the best hardware parameters in this case. So if you navigate to the kdif dashboard, you're able to see some training done behind the scene and try to figure out what is the best hardware parameters. And it will also show you like a graph seeing like what kind of parameter give you the best loss rate versus accuracy rate. And we could fast forward a little bit and see when the pipeline is finished. So you could see like while the pipeline is running, it would give you back the status of running. And once it's finished, it will tell you the pipeline is staying complete. And it will go into the next step to extract the best hardware parameter and go into the next phase and train with more iterations. And you can also see like the new artifact is produced. And if you put in like JSON files, you will also render in a JSON format. And at the end, once the training is finished, then we will go to KF serving and serve the model in the last steps. And once the and you could see like these are the best tuned hardware parameters and how the output is being tracked in this case. And then at the end, we will go ahead and do some inferencing. So you can see like the pipeline is being served. And we'll go ahead and trying to find what's the inference point over here. You could use this command to get the inference endpoint. And then we place it on a Jupyter notebook that could give us outputs. In this case, we can see the output is number 9. And then at the end, we'll produce some traffic and see how KF serving is doing the canary deployment. And once we have deployed it, we could use a monitoring dashboard called Kiali. It came with the default Istio deployment to track any traffic on the Istio platforms. So in this case, we currently have no traffic, but since we just generated traffic from our Jupyter notebooks, then otherwise you're able to see traffic is being split into like 90 and 10% between the defaults and canary version of the models. And this is the end of the demo. Thank you very much.
Thanks a lot, Tommy. I think that was a great end-to-end demonstration for not only Kubeflow pipelines with Techtron, but also, you know, the overall capabilities of Kubeflow. I mean, you saw kdif, which is the hyperparameter optimization engine. You saw, you know, the model serving part, which is enabled through KF serving. So I think that covered that nicely. So I think at the end, I would say, you know, we would invite all of you to get started on this project, right, and essentially get going, right? So please, this is the GitHub repository. These are the Slack channels, right? There is also a Slack channel with the same name into the Kubeflow community, right? I should update this slide, but KFP Techtron is also the name of the Slack channel in the Kubeflow Slack community. You can join there, but the best way is, you know, use the GitHub. If you want to use it, getting started guide, but if you want to, bonus, which is for us, if you want to contribute, I mean, starting with the developer guide, right? And if you have any questions, I mean, reach out to us, through the GitHub or through the Slack channels, right? We will be available. With that, thanks everyone. Thanks, Tommy. Thanks, Christian. And we will see you in the next session for the dojo around, with deep dives into other parts of the Kubeflow technology. Thanks, everyone.
Thanks, Animesh.
Thanks.
Thanks.